Exercise 4.2 of Calculus with Analytic Geometry, that is written by SM Yusuf. Previously, we have already done exercise 4.1. Now we have to do exercise 4.2. Exercise 4.2 evaluate from problems 1 to 22. These integrals are given here. We have to integrate these functions. We have to solve or simplify these integrals. So starting from question number 1. For solving these questions, you need to just memorize the table of the formulas of integrals. This is the table of integrals. You have to memorize all these formulas. That will be directly used in some of the questions, and in remaining questions we'll just use the substitution method, and then we can use all these formulas. So there's need to memorize all these formulas as well. So starting from the first question, we have to integrate dx over a square plus x square. Integration, this is basically 1 over square root of a square plus x square. We don't have any direct formula for this function to integrate it. But we had the formula for a square plus x square square root. But this is 1 over that function. So we cannot use this one's formula in that. So here, you know very well, this is a hint that how you can memorize this, like what kind of substitution we have to do in this question. You know that derivative of tangent theta is 1 over 1 plus x square. This is the same kind of function. This one can be treated as a square. So this is the derivative of tangent theta. So this is a hint that you can use the substitution as let x equals to a tangent of theta. Now, if we substitute x in this function as a tangent theta, then we must also know that what dx will mean. Take the derivative of this letting function on both sides. X will give us dx, a is a constant, derivative of tangent theta is secant square theta, and derivative of theta is d theta. Now substitute these values in this function. In place of dx, just replace this a secant square theta d theta divided by square root. A square will come as it is plus x square. X square means we have to take the square of this x value, that is a square tangent square of theta. So here we will get a square tangent square of theta. Now just simplify this integral. A secant square of theta is taken as it is. I have just separately written d theta. Take a square common from this square root. If I take a square common inside the square root, I will get 1 plus tangent square of theta. Now 1 plus tangent square of theta, you know very well that this is an identity and it is equals to secant square of theta. Take this square root, just solve this square root, we will get a secant theta. Now we can cancel a with a and secant theta with this 1 of secant theta. So we get integral secant theta d theta. Now use the table of integrals, use the direct value of answer of this integration of secant theta. Its direct answer is ln secant theta plus tangent theta plus c. Now our answer is in theta, but our question was in x. So we have to substitute back the value of theta so that we can get back the answer in x only. We cannot leave our question here because our starting function was in x and now it is in theta. So just replace theta in terms of x. So our starting letting function was x is equals to a tangent theta. Now one thing we know, we must have the value of tangent theta, that is we can separate the value of tangent theta from here. Just move a towards this one, x divided by. So we got the value of tangent theta. So replace tangent theta with x over a. So I have replaced tangent theta with x over a. Now I also need the value of secant theta. We know that 1 plus tangent square of theta is equals to secant square of theta. So secant of theta will be equals to 1 plus tangent square of theta square root. Replace the value of tangent square of theta. Tangent square of theta will be x square over a square. Take the LCM. This will be a square plus x square over a square square root. Separate the square root. in the numerator and also in the denominator. This will be cancelled out and we will get a square plus x square square root divided by a. So just replace this value with this secant theta. Now you can see that the denominator is same, so we can take the LCM. This will be square root a square plus x divided by a. We can also further simplify it. This is the property of ln, that we can separate the numerator and denominator as, just write the numerator. Now the denominator function can be written as minus ln of a. This is a property of log, that we can separate the fraction, plus this c. Now ln of a, this is a, can be any constant. This constant will also result any constant number. So we can merge these two constants and we can say, like, let's suppose this is a, any other constant. Two constants when added will give us any other constant. Question number 2. In question number 2, we have to take the integral of 1 over x square minus a square. Now again, it is to let some supposition here to substitute in it. For that purpose, just memorize that whenever you have this kind of function a square plus x square, then you have to take the substitution for x is equals to a tangent of theta. And whenever you have this kind of function x square minus a square, then you have to let x is equals to a secant of theta. Now let x equals to a secant of theta. Take the derivative on both sides. That will be dx equals to, a is a constant, derivative of secant theta will be secant theta tangent theta and d theta. Just substitute the values in this integral. After substituting the value, take a square common from this function, like we did earlier in the previous example. If I am solving just this denominator, just solving separately this denominator, this will be a square into secant square of theta minus 1 square root. Now you know that 1 plus tan square of theta is equals to secant square of theta. So tan square of theta will be secant square of theta minus 1. So we can replace this secant square of theta minus 1 with tangent square of theta. This will be a square tangent square of theta. So it will be a tangent of theta. So I have replaced this with this value. Now we can cancel a with a, tangent theta will tangent theta. So we got integral secant theta d theta and we got its answer. Now we have to find the value of secant theta and tangent theta. We let that x is equals to a secant theta. We can separate the secant theta value from here, that is x over a. So in place of secant theta, we have written x over a. Now we need to find out the value of tangent theta. You know that tangent square of theta is equals to secant square of theta minus 1. So tangent theta will be square root secant square of theta minus 1. So just put the value of secant square of theta here, that is x square over a square minus 1 square root. Simplify it, we will get this answer, tangent theta equals to square root x square minus a square divided by a. Just replace it with this answer, take the LCM, then just separate using the property of log, and this can be replaced with some other constant. I have used the capital C here. You can use any letter for the constant term now. Question number 3. Integration of tangent x dx. There is a direct formula value given in your table of integrals, but if this question come in your exams, like you have to evaluate that how you are going to calculate its answer, then you need to know its method. Tangent x can be replaced by sin x over cos x. If we make the derivative of cos x in the numerator, then we can use this integration formula, that is, if we have f dash of x over f of x dx. Like if we have a fraction and the denominator has its derivative in the numerator, then we can write it like ln f of x. Now you see, we have in the denominator cos x. The derivative of cos x is minus sin x. We can make minus sin x in the numerator. So we can use this formula. So I just need minus sign here. So I also wrote minus sign 2 times so that minus minus will again get back to plus. So we'll just take this minus sign outside and just consider this negative sign. Now cos x has the derivative minus sin x. So using this formula we will get ln cos of x. We can also leave our answer here because tangent x can be written, integration of tangent x can be written in this form and can also be written in this form. But we can further modify it as well. This is a property of log, that if log have some constant terms in its coefficient, we can move it in the power of the function. So it will be written in the power of function, and we know very well that anything, like for example a has the power minus 1, it can be written as 1 over a, so that we can make its power positive. So cos of x has the power negative, it will convert into 1 over cos of x, and 1 over cos of x will give us secant of x. Now integration of cot of x. Cot of x can be written as cos of x over sin x. Now the sin x has the derivative cos x. So using this formula again, we'll just write the ln this function sin of x, because the sin of x has the derivative cos of x. Integration of secant x dx. For integrating this secant of x, we need some more functions. We just need to multiply and divide with secant of x plus tangent x and secant of x plus tangent of x. Numerator will be multiplied with numerator, secant square of x plus secant x tangent x divided by this denominator. Now again we will use this formula, that is if the function denominator function has a derivative in numerator, so we can write this ln denominator function. Check that. Take the derivative of this denominator. Secant x will give us the derivative secant x tan x plus tangent x has derivative secant square of x. You see, this is the same function as the numerator. So we can write it like ln this denominator function plus constant of integration. Question number 6. Integration of cosecant x, the same thing as we did in question number 5. But here secant x, for secant x we use secant x plus tan x. Now for cosecant x we will multiply and divide with cosecant x minus cot x. Just multiply and just check this function has the derivative, this one numerator as it is, and just we'll write it like ln that function of denominator. Question number 7. Ax square plus 2bx plus c raised to power n. Whenever we have some function in multiplication form, we can just check that whether this bigger function has its derivative with it or not. If we check without power derivative, the derivative of this function will be 2ax plus 2b. If we observe that we have the same function but we don't have 2 here, but we can make 2 here by multiplying with 2 and dividing with 2. This division 1 by 2 will be taken aside and we will just consider this multiplication 2. Multiply it inside, we got the same derivative of this inner function. So now we can easily integrate it by using the power rule. So how we will just integrate it? Power plus 1 divided by that power plus 1 value. So we got its integration plus constant of integration. Question number 8. Integration of square root 1 plus x over 1 minus x. Just separate the square root on the numerator and denominator. Just to simplify, I am multiplying it with square root 1 plus x and 1 plus x. You can also multiply it with 1 minus x and 1 minus x division. It's up to us. Both will give us the same answer. Now, when we will multiply the numerators, both the functions are same. So it will be 1 plus x square, this square root. This will be cancelled and we will get just 1 plus x. Now, in the denominator, both the functions are different. They are multiplied with each other. Using the identity, we got 1 minus x square square root. Now we can separate it. like 1 divided by 1 over x square root plus x over this function. We know very well that this integration has a direct formula sine inverse of x. Now we have to integrate this function. Move this square root formula upside, we'll get just minus negative, that is negative 1 by 2. Now check the derivative of this function, that is minus 2x. Can we make this minus 2x here using this x? Yes. We just need minus and 2. So also divide it with here. Now this function has a derivative with it, so we can add 1 in the power and divide with it as well. Just simplify the powers, we will get this function 1 by 2 divided by 1 by 2. This 1 by 2 will be cancelled with this 1 by 2 and we will get this answer. Sine inverse of x minus square root 1 minus x square plus c. I hope up to question number 8 you understand well. In the next part, we'll start from the question number 9.